problem I'm about to show you is similar to SMO Junior. That stands for Singapore Math Olympiad. The junior section back in 2012, and I think it was problem 1. And like I said, I think it was problem 1. Now, it's a problem that's sort of contrived in the sense that it depends on an algebraic identity. So it's specified that A and B are the roots of this quadratic that has a parameter C. We're supposed to find the minimum value of the difference of the roots squared. Okay, that just smells like an algebraic identity, and sure enough, what we do is a couple things. First thing is we just use the factor theorem. Since A and B are specified to be roots, we can write them as the product of these linear factors. Okay, and then when you expand all of this out, minus A plus B presents as the coefficient of x, and the product of the roots just presents as the constant. Now you'll notice for this problem, this piece right up here behaves like the constant. I'll circle it. That entire piece would be the constant. You're used to just seeing C here in a quadratic, but in this particular case, this expression is going to be behaving like the constant. Okay, so that would be equal to AB. In other words, that would make this equal to AB, and that's what I've done down here, folks, as you can see. So you see what happens here. It works out rather nicely because just from examining this piece right here, we get that C is equal to minus A plus B. And that's just equating the coefficients. Okay, then as I stated earlier, this constant term is just equal to AB, just by inspection. This constant term, I won't write it down, but this constant term, this part right here, is equal to AB. And that's exactly what I did with this algebraic identity. Now it's not too hard to see this. A minus B quantity squared is A squared minus 2AB plus B squared. But if you subtract minus 4AB from A plus B squared, this is equality right here, right? Okay, so this algebraic identity is the whole reason you can do something ridiculous like this. All right, this looks kind of like, why would anybody even think of asking this question? Well, it's only because of this algebraic identity. Okay, so you see at this point it's just rote substitution. Notice that A plus B would be equal to minus C. I put the minus there. It's kind of superfluous because it's going to go away, but I think it documents what we did. That minus sign is what C is equal to minus the sum of the roots. And so I put it there, even though a lot of people would do that in their head, which I think is bad practice. Okay, now right here we have minus 4 times the constant term. Right here, minus 4 times the constant term is the same as minus 4 times AB, right? The constant term is AB. So we get this, and then we quickly get to this point right here. Okay, when we multiply through by 4. But now notice we caught a break because we are trying to minimize this expression, and this expression is flat out equal to C squared minus C over 3 plus 20. So this is a very straightforward complete the square exercise. This would be the very same thing as C minus, what's half of 1/3? Half of 1/3 is 1/6. Okay, so we have C minus 1/6 quantity squared. Now again, this is very elementary. A lot of times people are used to just an integer being here, but you're taking half of the coefficients to take advantage of an algebraic identity. And so C minus 1/6 quantity squared gives us C squared minus C over 3 because you have 2 times C times 1/6, right? But you also have 1/6 getting squared, and so you have to correct for that, so to speak, and so you would get 20 minus 1/6 squared, which is 1/36. Okay? Now the reason why this form is useful is because we can quickly identify what value of C is going to minimize this entire expression. See, if C is equal to 1/6 itself, you get a 0 right here. Otherwise, this would be a positive number. Okay? So it's clear that when c is equal to 1/6, that this is going to be minimum. Now, so what is the actual value? Well, gets down to just simplifying this piece right here. Okay, so 20 minus 1 over 36. Well, 20 times 36 is 720. So this would end up being 719 over 36. Just this constant right here, and of course it's still c minus 1 over 6 quantity squared. So it's very clear that this expression is minimal when c is equal to 1/6, like I said earlier. Okay, so c equals 1/6. Implies that this is a minimum value right here. Okay. Now this is kind of hard to check directly, but what we can do is we can note that 719 over 136 is approximately 20. It's a little bit less than 20, but we can say approximately 20, right? Because 20 times 36 is 720. So let's call this approximately 20. All right. Now let's pick a c other than 1/6. I've done something convenient down here. C is equal to 12. All right, that just made this easier to evaluate. Okay, so we pick c equals 12, not equal to 1/6, right? All right, and we anticipate a difference of the roots of being greater than the 719 over 36, which is alleged to be the minimum value. Okay, so what we get right here, folks, is two values. We'll call them x sub 1. This is a complete the square right here, very straightforward, complete the square. So we get x sub 1. Let's see, what do we got here? X sub 1 would be approximately 12, right, folks? Approximately 12. And then x sub 2, see, the square root of 40, folks, is approximately 6, right? It's approximately 6, so we get approximately 12 here, and then x sub 2, approximately 0. And we don't have to be perfect here, we're just trying to prove that c equals 1/6 leads to the difference squared being minimum. Okay, so we get 12 right here and 0 right here, and so notice that what is it? We're trying to minimize the difference of the squares. So this, you would have 12 minus, and again, an approximation, not, it's sort of crude, but not, it's sort of close. Okay. Okay, that's equal to 144. And again, keep in mind, I'm just using the fact that the square root of 40 is pretty close to 6, right? It's pretty close to 6, not too far away from 6. Okay, so we get 144 right here when we take the difference of these two approximate roots for a different constant. And up here, we've seen that this is 20, right? So you have reason to believe that this might actually be correct, okay? Anyway, that's it, folks. 719 over 36. Let me come up over here and write that down. It would be 719 over 36.